extremely distracting subtitles. But yeah, thanks everyone for being here. Thanks for taking time out of your evening / morning / whatever time zone you might be in today. And thank you to Women Who Code for having me here. I'm super excited to talk to you all today about some cool code and some cool concepts and fuzz testing, of course. Oh, come on. Yeah. So let's start a little bit about me and a little bit about the talk. Since this is a live chat, feel free to ask questions. I will do my best to answer as I can. But obviously it's going to be a little. I will rely on my moderator to help just in case I miss something. But so who am I? My name is Melissa Benua. I am a director of engineering with a startup called Imparticle. And I'm pretty easy to get a hold of. You can find me on Twitter at Queen of Code. You can find all the code that we're going to look at today on my GitHub account. There's also some references and some more documentation on my website. Pretty easy to find. Feel free to reach out with questions or to talk about other things. So I'm a director of engineering now, but I've worn a lot of hats over my years. I have been a software tester. I have been a back-end software engineer. I have done some product management, and now obviously I'm doing some technical leadership. So I'm going to start with a story though about software testing because I have a very strong software testing background. Software testing is sort of my passion. A lot of the things I do now revolve around shipping high-quality code very quickly. And so the story I'm going to tell you is from when I was an SDET at a very large company based here in Redmond for a search engine that you probably know about. We're not going to name any names. But so years ago, when I was relatively fresh in my career, I joined this company and I was an SDET on this very, very, very large scale web service. And one of the first things I owned when I joined this company was a testing service, and it was called the forking service. And this is going to be a serious test of the subtitling system as I say forking very carefully a good half dozen times in a row. So my service was known as the forking service, but annoyed devs also called it that forking service. And they also talk about that service that forked the test environment again, and we can't get any stuff pushed out to production. It was you get the idea. But what the service did was a thing called, well, I'm gonna get myself out. A thing called TTraffic, maybe something that you've heard about. And so what it did was it took a very small percentage of traffic from production, sanitized it, right, cleaned it up to make sure we didn't have any PII or any weird things in it, and then it would send it to a parallel environment for testing, right, for stabilization testing, to make sure that nothing crashed, nothing looked weird, that we could validate our monitors, et cetera, et cetera. And this is back before the days of continuous CI/CD. We didn't even have words for them at the time. And so back then we had long 6 to 8 week release periods and then a stabilization period of a couple of weeks. I'm sure some of you know what I'm talking about. And that stabilization period was sometimes really painful because a lot of code met in the middle and it was a mess. So we relied pretty heavily on the forking service in order to ensure that the code was stable and integrated and there weren't any major regressions at scale. So anyway, so I didn't invent that forking service. I didn't invent traffic keying. When I came and joined the team, it was already considered a pretty critical way to ensure that everything was stable. But there were obviously things that it missed. And as the owner of the service, I took it upon myself to think about how could I make this better? How could I help us find more issues? And so at the time, I had a pretty strong security interest, and we had a really cool internal security team that had published this set of done talk about fuzzing and then published a set of internal libraries. And so I took those libraries and I thought this is really cool. And I basically integrated these fuzzing libraries with the attacks inside them with our model of our domain-specific HTTP-style traffic and created something called the fuzzing service that I layered on top of our forking service. So say you had requests going to foo.com/whatever, then it would say foo.com/whatever %A %D semicolon alert. You get the idea. So it would take any existing request and just make it weird. So I worked on this thing. It was great. And so the day I turned it on was in the middle of one of our stabilization periods. And so I turned it on, and I got up from my desk, and I went to go and grab one of our free coffees. And as I was walking back from my coffee to my desk, I kept hearing very loud, angry voices complaining about what just happened to the dev environment, what just happened to our code, who we need to validate, who took the bed down. And by the time I was at my desk, I had several red bang emails and a couple of urgent items saying, whatever you did, please stop. The beds have all crashed. We can't finish validating the release. And so I went, oh, I must have done something really bad. Maybe I drowned, maybe I DOSed the beds or something, sent too much traffic. So I turned it off. And as as developers started digging into what happened, why all the machines cratered, they found 7 or 8 different crashing issues. And these were crashing issues on machines that had been running under stable fork traffic for sometimes days to weeks. As we continued to dig, some of these issues were really old. They were several releases old. So we kept finding all of these really old, we found these really old issues that we had in services that had been tested. Turns out some of them reproduced in production, but once or twice a month, not really a big deal, but they were all ticking time bombs. And so they worked frantically, they fixed all these crashing issues. And then the next time when they messaged me after a couple of them got in and they said, hey, Melissa, can you please do it again? Please turn this traffic on again. And I said, okay, but please don't yell at me this time. And I turned it back on and it crashed again. The beds cratered immediately, like that, back into the ground. So there were 3 or 4 more crashing bugs. So then again, they scrambled to fix this code. We did the cycle a couple of times until finally we stabilized, more or less, enough that we could ship the system. These were all like serious major issues that we had missed, sometimes for days and weeks. And we had a test team, we had lots of test resources, and yet somehow we still missed all these things. And we had all kinds of bugs. We had issues in our C++ web service. We had memory contamination. We had JavaScript vulnerability rendering, JavaScript vulnerabilities and rendering issues. We found other crashes, we found leaks, we found deadlocks, we found all kinds of things just for making our regular, plain old, everyday traffic look super weird. And some bugs were pretty easy to track down. Oh, well, we got a crash dump. Here's the line number. It looks like it was null. Yep, it was null. Okay, let's do a null check. And some of them took hours. We caught before it went live a cross-process memory contamination bug. That would have been nasty in production, right? Because cross-process memory contamination implies that you're leaking data, one person's data to somebody else. Thank God that never made it anywhere. So we found really cool and interesting bugs just for making our traffic look super weird. So I'm going to take a break. We're going to step back just for a minute here and lay down some definitions. So these are the definitions I'm going to use. I'm not going to claim that these are industry-wide generic definitions, but they should be pretty understandable. So we'll start with fuzz testing, right, which is what we're all here about. Fuzz testing is the act of generating random input in order to explore the boundaries of a system under test. Right, you're just trying to come up with, rather than having a human come up with ideas, because humans are limited, right? We only have one brain. We can only generate so many ideas at a time. Machines are unlimited, and that if you give them the right seeds, they can procedurally generate massive quantities of data in the time that I thought of, null, 0, 1. We'll see some more interesting pieces in a little bit. But they can apply interesting attacks. And so what is attack? An attack is a piece of data meant to drive out a specific class of bug. So cross-site scripting attacks, for example. SQL injection vulnerabilities, for example. And so manipulation then is a combination of an input, right? Some input and an attack. And we're going to talk about 3 types of manipulations today. We're going to talk about creation manipulation, which is substituting out your input, throwing the input away altogether, and replacing it instead with something generated from an attack. And we'll look at what those can look like in a minute. You can also do an insertion manipulation, which is taking your known input and then inserting an attack, in the middle, at the beginning, at the end, somewhere in there. And then finally, we have genetic manipulations, which are things you can do if you have white box access to the service under test, which basically continually modifies an input based on system behavior, right? If you're using code coverage, for example, you can concurrently, you can continually see the input change as you walk across the branches. So what are the keys to successful fuzzing? You really just need three things. You need a model. You need to understand what your data looks like in order to understand how you can break your data. And you need an attack set. You need to know how you are going to manipulate this data. And you need a plan, which is how you're going to apply your attacks to your model so you can intelligently target just the bits of code you're interested in. Because what happens without a model? Without a model, you are probably not going to fuzz anything very interesting to yourself. So let's talk about what is a model exactly. So HTTP, the HTTP protocol is a model. There's a data model here. Right? Data has to look a certain way in order for a web server to accept it. If you're missing any piece of this, the web server is not going to accept it. You're going to be thrown away by the web server, or worse, we won't even get to the web server. Right? HTTP requests have a method. That method has certain values, has to be valid. A URI has a format. It's made up of of the host name and the query parameters. Query parameters also have a format, right? They're an ampersand separated key value pair set. Likewise, headers also have a format. Header values have a format. A cookie header is a special header, but it has, yet again, another format. And so understanding what your data model looks like and how you're going to change it is the difference between having all of your fuzzing attacks rejected completely by IIS or Apache and having them actually go somewhere deep into your application where they can actually do some good. Because I don't know about you, but I don't get paid to test Apache. Nobody pays me to make sure that my web server is good. I get paid to deal with the services that we write. So I'm interested in testing those services. I don't care that Apache knows how to throw something away with an invalid method, an invalid verb. What I care about is if I pass in something really weird into my query parameter, that I don't accidentally leak all of my user data. So even if you're not in the HTTP world, if you're, accepting a JSON body, that also has a format, right? JSON has a very specific data model. You may care less about the HTTP parts. You may just be all about that post. Well, JSON has a format. You have to have JSON that is valid. Otherwise, all you're doing is testing your JSON parser. And, again, Newtonsoft doesn't pay me to test their JSON parser. It is interesting to test it, but it's a lot less interesting than making sure that once my JSON has been parsed and serialized, that my application does the correct thing when it receives strange inputs. Even if you're not in JSON, right, you can be in XML, the principle applies, right? You have to understand what your data model is in order to know how you're going to change it to do something fun. And speaking of fun, let's talk about attack selections. So attacks can be very, very simple, or they can be very, very complex. So an attack can be anything from a string of A's. It can be a couple A's, can be 2 A's. I'm constrained here by the limits of PowerPoint. It could be 1024 A's. That's an interesting number. Could be 4096 A's. It can be a lot of A's. And if I feel like I'm really harping on this A thing, it's because you get a lot of mileage out of seemingly simple inputs put in very weird places. It can get as complex as a SQL injection attack. You can do control characters. You can just imagine the fun I had pasting some of these control characters and other Unicode characters into PowerPoint. I was pretty sure it was going to crash. It chugged along quietly for like 3 or 4 minutes until it was like, yeah, okay, these characters are fine. XSS attacks, integer overflow, redirect attacks, the list goes on and on. I do want to pause and put a warning. You probably, if you're not a security engineer, you probably shouldn't be inventing attacks. Or, you know, perhaps at best you could be supplementing a known good list of attacks. And why do I say that? Coming up with attacks is actually a really hard problem. It is, there's a, you know, it's a full-time problem all by itself. And there are well-known and published lists that you can just use. You don't have to invent them. There's a tool called FuzzDB, which is open source on GitHub that the code makes pretty heavy usage. So FuzzDB lists all attacks that have been known to cause an exploit. And what you want to do is harness those attacks as much as possible in order to do something really cool and interesting. So let's say we've got, we're just going to do some fuzzing, but we're got a data model and we're going to fuzz that data model. But this, while it does look super fuzzed, is actually not useful at all. And that's because there was no plan or thought provided as to why things were fuzzed. Right, the data model, it was fuzzed within the data model, but it's probably not going to get anywhere useful because it doesn't have a valid verb. And even if it did have a valid verb, it doesn't have the correct URI. It's not going to go somewhere good. And even if it did have the correct host name, the path is not good. And even if that was good, a bunch of our headers are just outright broken, right? Or missing our cookie header at all. So it doesn't matter that we fuzz the internals of the cookie header because the actual header doesn't exist. And so without a plan, your fuzzing is going to be really scattershot. And if you fuzz too many things, you're going to have a hard time reproducing whatever issues you do find. You're going to have a lot of data just summarily rejected before it gets anywhere that you actually care about testing. So if you fuzz too many things, you're wasting your time. Likewise, if you don't fuzz enough things, you're also wasting your time. I spend a lot of time talking about CI/CD systems and services that ship immediately, and so I care a lot about time and efficiency. And so there's a sweet spot here, and in order to hit that sweet spot, you need to make a plan. So making a plan means figuring out how you're going to apply those super cool attacks to your smart data model. Right? It's things like, it's very silly to fuzz your HTTP method 100% of the time if that's going to just get rejected by your web server. It's very silly to fuzz your host name if you need the host name to always be accurate. It's very, you know, if you need an authorization header or your server will summarily reject the request, it's very silly to fuzz your authorization header very frequently. Perhaps, you know, it can be interesting to do it 1 or 2% of the time, but it's not going to be all that valid to you if 80% of your traffic has an invalid authorization header and gets kicked out by your auth gateway. So this allows you to worry just about the things that you care about breaking. You can do some much more impactful things like this. Also a fuzz request to some totally random website. But you see the verb here is correct. The URL is correct. The path is correct, but we've done something very interesting to the query line. Pretend there's more A's there, like 1,000 more. That could be very interesting, both from, you know, analyzing our memory usage on the server. What happens if our users send in unexpectedly large query parameters? Also because it's got spaces. And if you look at the rest of the request, it all looks great. And then you see within the cookie, we have intelligently parsed that not only is this a cookie header that has a certain format, but we've just taken the values of one of those parameters in the cookie and we've just fuzzed it. And I happen to know that this is a user ID, and that's very interesting. If we're using this user ID anywhere on the page, and we're just accepting that, yeah, it should be fine, because who would ever mess with their own cookie? There may be vulnerabilities there. Right, so it's very interesting to put a JavaScript, to trigger a JavaScript alert to see if there are any vulnerabilities if we're not sanitizing our inputs. Right, this is a very interesting fuzzed request, and all we did was take all of the other pieces we already have and apply a plan to them. So this is also a very good fuzzed request. It doesn't actually fuzz any part of the HTTP method because it turns out we needed that in order to get the traffic where it needed to go. It did fuzz some values, but it fuzzed them in a way that doesn't break JSON. You can still, your JSON parse, your basic JSON will absolutely pass parsing, right? There's a field that was a number, and it just put in a different number. There's a field that is a string. It's still a string. And again, this could turn out something very, very interesting. But how do we know we've turned up something very, very interesting? So there's a few things you can check. You can look at your metrics, right? You can look at especially memory usage. Memory usage is great for figuring out the delta between what your traffic looks like under normal, normal in production versus what it looks like when you are testing with slightly strange traffic. It'll let you know if you're leaking memory, if you have weird memory usage, if your CPU is spiking awfully high, you've got some potential for vulnerabilities there. Of course, you can look at your logs. You can look at any core dumps you might have or any exception stack traces. Also very useful to look for side effects, especially if you are trying to do cross-site scripting vulnerabilities or SQL injection vulnerabilities. You want to make sure your attacks are crafted to trigger side effects, so you'll know, oh, whoops, I've found a vulnerability in my JavaScript, or I've found a vulnerability where I'm not sanitizing inputs and we're accidentally writing to this table. You can also use an oracle to help you determine good behavior from bad behavior automatically. Right, so the difference between just looking at your graphs visually and having an oracle do it is an oracle can make an automated judgment call about the things you found at scale. Right, so it can say, my CPU for this run was over threshold. It was greater than 10% higher of my last 10 runs. Therefore, I need to flag an error. Somebody needs to investigate. There's probably a new bug here. So what exactly can you find? You can find crashes. You can find buffer overflows, you can find exceptions, you can find memory problems, right? You can find places where you're leaking memory, where you're not disposing it, where you're allocating way too aggressively. You can find thread contamination, right? Where places where threads are writing over each other's memory. Nasty, but it happens. Of course, obviously, you can find security exploits, SQL injection, XSS code execution, et cetera, especially if you're monitoring for side effects. And so some of these are easier to find than others, right? Crashes are really easy to know when they've happened. Exploits are a little trickier, but there's always a little bit of art. I've found in my experience that sometimes generating the fuzz traffic is a much easier problem than figuring out exactly what's gone wrong and all of the things that it's driven out. So we're going to look at some code. So if you are interested, anything I'm about to show you is up on an open source repo. You can play with it. It is in a super cool thing called .NET Core. Let's see how this works. So what we are going to do, this is the library, here it is, we are going to generate some fuzz traffic. Here we go. Hopefully it behaves. There you. So here we are. We're generating 5 requests to some totally random website. You can see the requests are very simple. We've got some headers. This is a weird artifact of outputting. It's actually one header broken up. That will be important in a minute. So here are our requests. We want to make them weird. So here we've gone and made them really weird. You can see the method is still correct, the request URI, this part is fine, the path is fine, the existing query parameters are fine, but actually we've taken this one and injected some crazy. Let's see if you have any other fuzzes in here. Nope, that one's got one. Here we've injected some different crazy intelligently inside the header. You see that .NET is still recognizing this is totally a valid header. It's just in the middle of it. But something very interesting could happen here. Here we have, we've injected into the path and also the query line. You see we've done some very, very interesting things here in our fuzz request. Some of them look quite simple, but they're all changed in a slightly exciting way. So let's see what happens if we send these to the server. So 2 of them were accepted, probably fine. 1 of them 404, that's the one with the bad path. But this one is interesting, right? Any 500 server response to a fuzzed request is suspicious. Super suspicious. So if I was testing here, I would want to look at, okay, what was up with this request, something, and I would want to repro to understand why my server is giving a 500 here. The most important thing about any fuzzer is that it should be repeatable. So here we have a random seed to ensure we get the same results every time. If I were to change this to something else, just to show you that this is real and not can, we can run it again on my very sad old machine here. We will get a totally different set of fuzz requests. I promised you A's. For those following along, there's the A's. Look how many of them there are. I'm scrolling. You can't see it going. There are so many A's here. So I've replaced one of my header names with nothing but A's. And let's see what the server's going to do about it. It's probably mad. Oh, it wasn't mad. It accepted my weird header. That's interesting. That's interesting. So again, you can see how we can make some very interesting traffic that you never could have come up with on your own as a tester. That has interesting security checks that, again, you probably could never at scale apply as a security tester. This applies, it generates, I generated 5 of these in a couple milliseconds. I can generate 60, 100, 50, 50,000 requests per second. And I can come up with 50,000 different unique test cases per second that are model aware and that are testing what I care about in my application. There's no way that I could do that as a person. There's no way that a team of 10 testers or security people or developers could do that. There's no way 100 could come up with that many test cases. And so this is the power of fuzz testing, is it takes your knowledge and your expertise of your systems and scales it out really, really broadly across your services. I do have some references that I promised. So these slides are up on my slideshare.net. They're also linked off of my website. But here are some references ranging from Fuzzing book, which is a great intro level, intro to pretty deep experience for hands-on fuzzing. AFL, if you don't want to screw around with implementing your own fuzzer, you just want to grab a pre-canned one. Yes, and the link to the repo is in the chat. FuzzDB is where all of my attacks came from because I'm not inventing that. Microsoft actually recently published something called Wrestler Fuzzer, which claims to be a stateful open source REST API fuzzing tool. I haven't used it yet, but we've been all excited about it all day today. And of course, if you are using Docker, you can run Kali Linux, and there are lots of built-in security tools, including for fuzzing there. That said, I think we are right here exactly at time, so I'm happy to answer some questions. If nobody has questions, we can just play with fuzz traffic for 5 minutes because I get a lot of joy out of just dumping random seeds in and seeing what comes out. But yeah, thank you, everybody. Here's my contact information, and I'm happy to take any questions you might have. Like I said, if you don't have any questions, we're just going to look at fuzz traffic over and over again. See what other interesting random seeds. So I'm going to run it again here. Drag it back over here. Yep, there's all those A's again. And so this looks strange because it looks like this is part of how Microsoft, how the .NET runtime is continuing to recognize that this is 3 different values on the same header. That's why it's there, and that's how I know I didn't break the format. Is this a game? It is not a game, but it could be a game. I certainly spend an inordinate amount of time looking at it and messing around. Oh my god, there's too many A's. I can't deal with that many A's. Let's get a different random seed. Maybe there'll be fewer A's. Or maybe there'll be more, you never know. Yep, a lot of A's again. But otherwise different. So tempting to put drop table X in the test. I don't need to. It's actually in my attacks. It's in there. Well, I don't know if drop tables is in there, but the FuzzDB fuzzer does have, let's see, attacks for, let's see, SQL injection, exploit, MS SQL enumeration. So it does have enumeration. Does create tables. So these are all in the live attacks that it's running. MySQL injection. Pretty interesting attacks in here. Yeah, it's not like I could put a drop tables in there. Wouldn't be. It's not my fault. Then you do enter a little bit of a gray area. I definitely would only do that to my services that I'm testing. Perhaps not in production, just in case. But I know the team against which I'm running these fuzzing tests, so I have faith. I have faith in their abilities. So yeah, you see there's a bunch of SQL injection here, XML attached, people who know XML. Many interesting things. Various form and sundry of encodings of the LT character, because that could be interesting. And if you do nothing else but go and browse through the FuzzDB attacks, I think you will have gotten something very interesting out of the session, because people get really creative with this stuff. Any other questions or something that anybody wants to see?
Melissa, I got one question during the session. Let me read it out. It's from Esther. Japanese or Korean Unicode characters are useful.
Yes, Unicode characters are super useful, as you can see from all of these various encodings of LT. Here's an attack. It's just control characters, various representations of the null byte. Here you can see where PowerPoint got really mad at me. Visual Studio, you see, is also getting a little annoyed. Hex vals, escape codes. Again, look, Visual Studio's, it's a little unhappy with me. Super useful, super useful.
Amazing.
Can really wreck somebody's day with JSON fuzzing. Let's see, what else do we have that's interesting here? Lots of exciting strings. My brain can't even parse what's happening here. All right, I think, are we at time?
Yeah.
All right.
We still have 4 minutes to go. So if anyone have questions, so we can wait. Otherwise, thanks again, Melissa. It was really wonderful talk for me as well. I just have first talk on fuzzy testing or something on this topic, and I really enjoyed. And through chat, I have checked like participants have already enjoyed it. It was amazing. Thanks again.
Yes,
Thank you.
Thank you for having me. I'm happy to hang out for a few minutes if anybody has questions. Again, questions or things you want to see.
Yeah, for sure.
Oops, I'm going to turn off these subtitles, though. They are, in fact, super distracting.
Exactly.
But very impressed with PowerPoint and their subtitling system. How was that? Live subtitles. Running through some random service on the internet. I don't know what it's called. Might start with a B. question, what is fuzz testing used for? So fuzz testing is used for testing at scale to come up with inputs that humans never would have come up with. Whether it's commonly used in security testing, less commonly used in more general QA and automation testing. Chaos engineering is a similar principle, right, where you come up with lots and lots and lots and lots of crazy inputs as a seed, and then let the computers come up with orders of magnitude more in order to explore the boundaries of your system and how it behaves under interesting conditions. So I'll use it for validating my QA environment. I'll send a small amount continuously running. Because there's a time component to fuzz testing, the longer you run it for, the better you get, the better results you get. Up to a point where you eventually get diminishing returns, and how much traffic that is or how long that is sort of depends on how many requests you want to do per second and how aggressive you are about your making a really good plan. You can integrate fuzz testing into your unit test as long as you're very strict about using a good random seed. You can integrate them into you can have them as integration tests. You can have them running end to end. You can have them running at pretty much any point in your system lifecycle and architecture, depending on how repeatable you make them. Right. The worst thing we can have in a unit test is one that's not the same from run to run, or one that we can't reproduce easily. Nobody likes intermittent failures in their unit tests. Any other questions? Here's some attacks for fuzzing a file upload service. Things that should be rejected. Very all-purpose, this FuzzDB. Do one more here just for fun. Oh, I didn't see any A's. Sometimes that happens. Something happened though. There's some more JavaScript unclick exciting things. I'm sure you're always sanitize your input, friends. Never not sanitize your input. Here, it just inserted a space, made the query line strange. Control characters, some scripting. Yep. Very exciting.
Exactly. Thanks again, Melissa. Forgive me if I'm mispronouncing your name. Sorry for that. And thanks again, everyone, for joining. And it was really amazing talk. Let's meet you in another, interesting event. There are a few workshops going to take place just now. You can join them and enjoy there. Thank you. Thanks for joining. And thanks again, Melissa, for a wonderful talk. Happy to see you.
Yeah, thank you. We'll see you all around the conference.
Yeah, again, inshallah. All right. I have posted link for the event. If you want to check, you can go through the basically event file and can see amazing talks, workshop to join them.